Hello everyone. Today I will do the presentation for my final project. The current world is information explosion world and people receive huge amount of news, documents and text content. This amount of text requests to be effectively summarized for use. It is impossible to do that all by human, while automated text summarization is an important technology to solve this problem. I developed a text summarization tool which is able to do automatic text summarization. Let me introduce some background of the text summarization. First of all, why text summarization is important? There are a couple of reasons. Summaries save your reading time and it's easier to select the document with summary. Reading the short brief of the long documents or books. Then you decide to continue or not. You will find something you like and save your time. Summary improve the document index. Reader is easier to find the document and also save manpower to create summary if using automatic text summarization. Text summarization will help to custom question answering systems. It is impossible for an answer machine to answer a question by very long text. It must be short description, and the short description also be used in commercial service, such as Apple Watch, to display a very short description, such as news, weather, or something else. But it cannot be long text on the watch. Which text summarization methods are using? One is called extractive summarization. The sentences are selected from the original document. Another one is abstract summarization. The new sentences are generated and not in the original documents. Let's talk about the extractive summarization. On previous slide, we talked a little bit about the extractive summarization. It is a subset of sentence from the original text. It could be summarized from one document or multiple documents. How does the extractive summarization system work? In order to understand how the extractive summarization system works, there are a couple independent tasks will be performed. First, construct an intermediate representation of the input text, which expresses the main aspect of the text. And second, score the sentence based on the representation. And third, we set a summary comprising a number of sentences. We will talk about the extractive summarized algorithms. There are a lot of algorithms published. I will introduce some popular algorithms. LUM, text range, LSA, latent sentence analysis, LES ranking, sum basic, KL sum. LUM algorithm, published by H.P. Lum in 1958, is heuristic method to extract summary. It select keywords and then rank the sentence, and then pick the highest score sentence from each paragraph. Text rank algorithm. It is published in 2004. The idea is coming from PageRank algorithm. It is a direct and weight graphic. It initials each turn to 1, iterate ranking until conversion. It picks the highly scored keywords. It is a supervised approach. Latency Semantic Analysis (LSA). It published in 2004. The algorithm uses a turn-sentence matrix and put singular value decomposition (SVD) on the turn-sentence matrix. Calculate the sentence have most of the variance in the data. Pick those sentences with highest singular values. LES Rand. It published in 2004. The idea is treat each sentence as node and calculate similarity of the sentence, and then choose the cosine threshold interpretation of the centrality, and make the graph-based centrality scoring of the sentence. Finally, pick the sentence in the cast are more central to the topic. Adjective summarization. The method will generate a new sentence like human reading the text and create the abstract. It could be used one document or multiple documents. In current years, the machine learning is widely used for adjective summarization, especially the neural network such as sequence-to-sequence learning. Let me show you the final project text summarization tool high-level diagram. The UI is designed by using FAC. FAC is a lightweight WSGI web application framework. It is designed to make getting started quick and easy, with the ability to scale up to complex application. The core is the intermediate layer, which supports extendable and provides transparent surface between UI and the lower layer. The lower layer will use third-party library, which provides the text summarization algorithms. So I randomly pick test data from CMM News today. We'll do a manual test. The data is what is going on with hardware and sales. Nobody knows. The test case 1 is to create a summary of 2 sentences. First off, we use LUM algorithm. The result shows on the screen. This algorithm is test ring, and the result is similar with LUM algorithm. This algorithm is latent semantic analysis (LSA). The result is different with the LUM and the test ring algorithm. In this test case, I use LES ranking. To be honest, I like this result the best. How do you think? Another test case is to generate only one sentence. Let's check the LUM algorithm result on this slide. So here is the test ring algorithm result for only one sentence. This is the latent semantic analysis (LSA) of one sentence test result. And here is the LES rank test result. . Rule is the most widely used for automatic evaluations. The test results are LES rank performs better on Rule 1 average F measure. LAS is better on Rule 1 average P. And LUM is better on Rule 1 average R record. LES, RAN, and Rule are better in Rule 2. LES RAN wins Rule 3 and Rule 4. The major future improvement is using neural network. The sequence-to-sequence learning abstract summarization has a much better performance than extractive summarization, and the document context and recurrent neural networks such as normal document context sequence-to-sequence model even has a better rules result than Google sequence-to-sequence, and this test summarization tool is extendable. It is easy to add state-of-the-art summarization approaches. In here, I'd like to thank you all and have a good one.